1/15 of a teaspoon. That's how much water the average single interaction with ChatGPT uses. According to Sam Altman, the boss of OpenAI, so if you type, "Can you help me solve this maths problem?" That's a drop. Or, "Can I put lime instead of lemon in this recipe?" That's a drop. Or, "Why is the sky blue? Help me write this email. Help me improve my website code." Mr. Altman claims there are 1 billion messages sent to ChatGPT every day. And ChatGPT is just one AI bot. Chuck-in, Gemini, DeepSeek, Claude, and others. It's clear that AI revolution is a thirsty one. Striking though it is, some experts are more than a little skeptical of Sam Altman's estimates on water usage. At this point, there was just not enough information for me to agree with or trust the number. Their number was perhaps referring to some tiny models. We are considering a medium-sized large language model that's the size of GPT-3. Basically, if you write an email or ask some questions, if you have 10 to 50 queries, you are going to be consuming roughly 500 ml of water. This calculation includes water used in cooling and electricity generation. The BBC asked OpenAI for more details about Sam Altman estimates, but the company declined. Either way, it's clear AI uses a lot of water. But why? Every time you send a prompt to an AI, it has to turn complex calculation to understand and respond. This work is done by the most powerful and specialized computer chips in the world, housed inside enormous data centers. Even before users can send prompts, the training process for the models uses the chips to carry out intense work, and all that extra power means the hardware can overheat and become damaged if not cooled properly. Most data centers use air cooling systems, which was fine until AI came along. But now, because these data centers and the infrastructure that's going in is so much more energy intensive, there are liquid cooling approaches that are now being implemented. For liquid cooling, the water must be cleaned to prevent bacteria growing or clogs and corrosion in the system, which means using mostly drinking water. Here is how the most common liquid cooling process works. It begins by piping coolant over processing chips within the servers. This cooling liquid absorbs the heat and takes it away from electrics to heat exchange unit. Water is used to reduce the temperature of a coolant. The coolant then recirculates back to cool the servers. Meanwhile, the now hot water is piped to cooling waters, where a combination of fans and water vapor dissipate the heat, cooling the water. Some of the water evaporates in that process, while the rest is recirculated through the cooling process several times before being discharged back into the nearby water source. Overall, up to 80% of the water evaporates. What it means is that this type of water is gone, and that we are extracting water from a water circuit that is necessary for irrigation, for human consumption and hygiene. Communities around the world concerned about data centers putting stress on water sources and electricity grids are pushing back. Protests have been held in Spain, India, Chile, Uruguay, and parts of the US. And it's not just the operation within the data center that need water. Generating the electricity to run them requires a lot of water too, because power plants like coal, gas and nuclear heat water to create steam, which drives a turbine. The International Energy Agency has said electricity demand for AI optimized data centers is expected to increase by 400% by 2030 to 300 terawatt hours. That's roughly the electricity consumption of the whole of the UK for a year. And aside from electricity, water is also needed when manufacturing the semiconductor chips used to run AI. So, water is both used directly and indirectly in the whole supply and creation chain of AI technology. It is used for refination of the critical raw materials that are needed to create the hardware of AI. Getting accurate figures on how much water it takes to build AI systems and run them is difficult. Google, Meta, and Microsoft release annual figures showing that their data centers use billions of liters of water every year from local sources, but none of them indicate how much of it is due to AI. Most tech giants recognize the impact it's having. Many, including Google, Microsoft, and Meta, have pledged to be water neutral by 2030. We hope that can happen. There is a long way to go to get to those kind of numbers. Part of what we hope to see is, across the industry, a range of innovations that allow us to maybe minimize the use of water. Companies are trialing, for example, ways to cool data centers without evaporating any water at all, and to use the heat that's generated to warm homes. There are also experiments to move data centers away from communities entirely under the sea to the Arctic or even off the planet. Can we actually put capacity out in space? It's very early stage. So what we at Entity are looking at is, can we launch satellites that can at least do some more backup oriented or other oriented tasks? Those skeptics point to the many hurdles that need to be overcome. There is optimism too about a more sustainable future. Let's remember that Gen AI capability is still very young. It's moved exponentially fast, but as an industry and as a use, it is still young. Ideally, we can learn together as a society and as a world society. How do we minimize against the use of water and energy? Because this is all a world resource when we talk about water.